For doing any kind of geospatial studies, the data scale, when I say scale, scale is of spatial as well as temporal.
Hmm.
So if you have data available for the desired scale, we can work on any kind of research and decision support system. But the challenge is data availability. If you have data available for farm scale, whatever we are planning to do, that's perfect. For that reason, we do a lot of field experiment to collect data from the field and to simulate in the models.
Welcome to the Crop Science Podcast Show, brought to you by Wisenetics. I am Brian Arnell, and I'm coming to you from the campus of Oklahoma State University. Today, I'm excited to have on Dr. Prakash Kumar Jha. Prakash works in the field of crop modeling, geospatial sciences, agriculture physics, climate, and environmental sciences. He received his PhD from Michigan State University. Prakash, thank you so much for joining us today. How are you doing?
Thank you. Thank you, Dr. Arnold, for having me on the podcast. And I'm following your podcast from last three months. So it's been a pleasure to be here.
Oh, fantastic. So, share with our audience. I always love to get a little personal note. Share with our audience, how did you end up going from India? How did you end up at Mississippi State University doing climate science?
Long story. I'm from a state called Bihar in India, and my hometown starts from Madhubani. And M to M, and now Mississippi. So it's a great journey for me. What I did after my high school, I did my undergrad in agriculture sciences from Banaras Hindu University. And then I did my master's in environmental sciences from one of the premier institute in India,
Mhm.
that is called Indian Agriculture Research Institute in New Delhi. After finishing my master's, I moved to US for my PhD in 2015, PhD in crop and soil science at Michigan State University. And I worked with Dr. Amor Ines. He is a senior crop modeler in the Michigan State. So that's how I came to start my grad life here.
I was actually at your university very, very long time ago. I always loved my trips to New Delhi and India. I always appreciated the people, the culture, and the food. As long as I don't go too far south into the Hyderabad area and get too much of that spice, I love the food, and I always ate well. So tell us a little bit about what your research program's focusing on right now.
Right now, we focus more on integrating remote sensing, crop modeling, and the climate change work. So, what we do work on the field scale,
Hmm.
the computer simulation scale, as well as computer modeling, as well as climate modeling. So, that's how we integrate all those components into our research system to formulate kind of decision support system for growers at farm scale, at landscape scale, and at country scale.
Hmm.
Like US, like currently we are working on USAID at country scale, but commodity farmers at farm scale. So varies from farm scale to country scale as well.
So that's absolutely fascinating. Let's dive in a little bit. I want to discuss a little bit about the challenges of the two aspects of what you're doing, at least as far as I see it. So I'm an agronomist, soil scientist.
Mhm.
What are the challenges when looking at both the farm scale and the like the landscape or the watershed or grain shed or larger scale? So kind of dive into some of the challenges you experience on both sides of that resolution.
Right. For doing any kind of geospatial studies, the data scale, when I say scale, scale is of spatial as well as temporal.
Hmm.
So if you have data available for the desired scale, we can work on any kind of research and decision support system. But the challenge is data availability. If you have data available for farm scale, whatever we are planning to do, that's perfect. For that reason, we do a lot of field experiment to collect data from the field and to simulate in the models. And for country scale, we rely on a lot of secondary data sets from that country PIs or maybe other sources on the website where we can get those data from the country scale. So when we work on country scale, we have challenges of getting data sets. And for that, we do a lot of data correction, like call as bias correction or downscaling to fit into our model. So that kind of challenges we do have.
What about on the farm scale? What challenges present itself on that farm scale side?
At farm skill side, we have major challenges of data variability among the field, among the growers, as well as different crop types, crop variety type, practices type. So it varies with different crop species, varieties, as well as different practices on that varieties. So that's how we need to have a common balance or a scale on the data used for models, where we can integrate those data into a single model, or can we calibrate those models based on different practices, right? So that is a major challenge in terms of field scale, how to collect data on time and how to convert those data into models.
So this is always a challenge I have when trying to take information or create usable and scalable products.
Mhm.
When you work with models, and I'm going to just say it in my words, and you can correct it because I'm probably wrong. When you work with models, uh, the data, as you mentioned, is the most important thing. So the amount of data, the history of the data, and the quality of data.
Mhm.
And so the more data associated with that specific location, that specific practice is important. But in a perfect world, and you're doing a nitrogen model or a yield model, you have all the data.
Yes.
All the data means a lot of work
Mhm.
and a lot of data put. How do you balance wanting all the data with accepting an okay amount of data to get the results? Where how do you approach that in your work?
This is a great question, Dr. Arnell. So basically, in the modeling field, we say as a minimum data set, MDS concept.
Hmm.
So MDS concept where you can use the model. But if you are a model developer, then you need more layer of data sets. For a model user, in terms of decision making, we have minimum data sets of weather, soil, and the basic crop management. So we go to that layer of data sets. When it comes to a developer like us, when we work in the background, how to develop the model, for that we need a lot of temperature response curve, photo response curve, fertilizer response curve, and that fit into the crop model using different computer programming. That needs a different layer of data. And when we have a model, a kind of mm, combination with different scale, let's say I want to combine my crop model with the hydrological model,
Hmm.
then there is a major challenge of upscaling or downscaling the data. So these are major challenges where we work on what layer and how we use the data.
All right, so I'm going to go back. I'm an agronomist, so I misspeak. It's like an agronomist talking about economics. I'm always going to do a little bit wrong, so the economists always correct me. So on your part, correct me as I'm explaining the use of models and the use of this kind of technology to a farmer. At least in my explanation, I say if it's an easy button, meaning all you do is push a button that says this is my place and go, you're getting what could be a very accurate result, but it might not be precise. And as you add more specific data, you improve the precision. Is that a correct way to explain it?
You're close to that, but we need to calibrate or validate the model. So a modeler cannot use model at each and every location with all the data sets. If you have all the data sets, it's easy to use the model, right?
Yeah.
Let's say I'm in US, I want to work for Australia or Europe or maybe other part of Africa. We do not have all those data sets. So what we do, we calibrate the models at different location
Hmm.
for different varieties, getting genetic coefficients of those varieties, and so that we can run the model at different locations, saving time, saving resources, and we can have better results for different analysis what we can do.
I think that, Prakash, you said something extremely important to me as a precision ag. So I'm also precision ag,
Mhm.
worked in sensors technology for 20 years now. Is that especially as we're seeing more technology hit the marketplace, these soil sensors, in situ soil sensors and stuff, is that I always share with the people that are asking about it is that the technology is usually quite good. My question always comes back to the calibration or the library of data that it's pulling from. And you being in Mississippi is beautiful because Mississippi and Oklahoma, while they're not alike, they're also not alike the Corn Belt. And much of the information that first hits the marketplace is Corn Belt centric. It's at Iowa, Illinois, Indiana, Minnesota. And surprising to the audience or not, Mississippi and Oklahoma are nothing like the Corn Belt.
Mhm.
And so it's always important to ask when producers are asking me about technologies is to ask those that are selling it about their calibration sets. Do you have Southern Great Plains calibration? Do you have Southeast US calibration? Or are you working off of a UK? Some of the models I've seen are heavily UK, and some are heavily Corn Belt. And I always feel that that's an important point to share with the adoption of technology.
This is a great point. So when we talk about the regional use of model, we definitely need to have data sets from the regional area where we can calibrate the model. However, those technology, when it comes to the market or to the user, they always focus on the consumer area or niche where they are.
Hmm.
But what we do as a crop modeler, we integrate different layer of data sets or information where we do not need to have exact sensors or data sets at the field. So we have data set from satellite, from the drone, from the simulation models. We integrate those into different scales and combine them as a final decision support system. So for us, we do not need to be a consumer market scenario where we need to have kind of any new sensors available or not. So for us, we are in different game. We work on different set of data sets. For your point, why we need to have a focus on different cropping system or different core zone where we have
Hmm.
corn, soybean, or maybe cotton base, whatever we need to have. For that, we need to collaborate. For modelers, collaboration is a key.
Hmm.
For those areas where we cannot work or we do not have data sets, we collaborate with the faculties. So I do have collaboration with faculty from Purdue, Michigan State, Iowa. We get data source or data sets from them to calibrate our models. So the collaboration is a key for any climate or crop modeler for to get the data from that sources.
Fantastic. So, folks, you're listening to the Crop Science Podcast Show brought to you by Wyzenetics. And today we have Dr. Prakash Kumar Jha. He is with Mississippi State University as a agricultural climatologist. And so, Prakash, as we dive into kind of a different realm of what we're doing today and talking about, what is how is the climate change impacting agriculture on a global scale?
Oh, this is a $1 million question. Climate change has significant impact on crop productivity as well as quality of the
Hmm.
crop product. So what we see nowadays, the change in the average temperature, change in the rainfall pattern. When I say change, when it could be positive as well as negative in
Hmm.
terms of rainfall, and mostly positive in terms of carbon dioxide and temperature. And when we talk about the climate change impact, the major impact is of because of high temperature and especially nighttime temperature. When we talk of nighttime temperature, nobody talks about the nighttime activity of the plant. And as per climate change scenario, if you see all the report from IPCC and other agencies, we have significant change in nighttime temperature. That impacts the quality of the crop. And in most of the region across the globe, if you see nighttime temperature has been increasing in the last few decades. And when we talk about rainfall, we have heavy rainfall in small period of time, maybe 2 or 3 days. We have flooding. We cannot go with implements or equipments at the field. Sometimes we have drought for 7 to 15 days where we cannot do farm decision system. Let's say any chemical application or any kind of fertilizer, pesticide, whatever we apply, all relates with water availability in the field. So these are major impact on crop productivity. And when we talk about climate change, CO2, carbon dioxide is increasing nowadays. It's around 430 ppm, right? And when we talk about the impact of CO2, CO2 helps in more biomass production, but
Hmm.
somehow we have to trade off between biomass and quality. And that's why the nitrogen component, which is you are expert of nitrogen, where we think on how we can balance or trade off between biomass and nitrogen. So the CO2 has significant impact on quality as well. So we need to think on what area we are working on or specific research where we need to emphasize more on impact of climate change. It is very broad and 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 it relates with the sustainability as well.
Well, so you kind of brought up something interesting that also goes into some of your bio stuff that I have here is that, we're talking about increased carbons, increased CO2, which could increase biomass, which actually increases the creation of carbon and could influence how much carbon we're putting in the soil. So, how do we look at the adaptation and mitigation practices, and how do we quantify those into the what we're now calling the carbon economy or carbon market?
Oh, for our audience, I can just explain a difference between adaptation and mitigation because there's a hairline difference and we need to understand that. Adaptation is the practices where we can kind of manage the impact based on different practices what we do, like water management, shifting planting window, choosing best cultivar. These are called adaptation practices. When we talk about mitigation, we need to reduce the cause of the climate change. So that is called mitigating,
Hmm.
reducing like uh, carbon sequestration and slow release fertilizers, where we reduce the emission of those gases. So our role is to educate growers about different adaptation and mitigation practices and how we can do that using a lot of climate models. We analyze the impact of different um, time period of climate change and what will be the scenario, and then we go to the growers that okay, let's see, there's a planting window of 15 to 20 days or maybe 1 month for you, and we have witnessed that okay, next 10 years will be warmer during planting time or maybe
Hmm.
a dry period, so you can shift the planting window. Similarly, you can shift your practices like irrigation and fertilizer. So those kind of practices at the farm, which is called strategy. And as an audience, we need to also understand difference between strategy and tactical decisions. So there are basic difference between farm management strategy, which comes under mostly under adaptation
Hmm.
practices, but there's a tactical strategy, which means when something is going to be happen for sure in the field, how best we can cope with that those situations. So the tactical and adaptation strategy is a broader term. In terms of mitigation for soil carbon, we do a lot of soil carbon sequestration, having cover crops, slow release fertilizers, and a lot of other practices we do at the field scale for mitigation. So I just wanted to differentiate between adaptation and mitigation.
No, that's absolutely perfect. So now that we say that, now that bringing that in is like now the quantification of carbon,
Mhm.
which as a soil scientist, quantifying carbon in the soil, let's just say presents its challenges on the field side. So let's talk about the modeling side of quantifying carbon.
I will come back to the field set, then I will come to the
Yeah.
modeling. So when we do sampling, we need a lot of sampling for soil carbon at different depth, and then we need sampling of biogeochemical studies like microbiological movement, and
Hmm.
then what kind of residue we are having in the field. So a lot of sampling component, and I'm connecting now that to the modeling. For modeling, we need
Hmm.
these layers. We need layers that we need data from soil carbon at different depth. We need residue use. We need what kind of microbial community
Hmm.
in that field. So we have nowadays a lot of models which can simulate biogeochemical carbon dynamics,
Hmm.
and those kind of models can help into more explanation of how microbial community helps in the movement of soil carbon under different layers, labile to non-labile, and then how we can use that for long term, and what kind of crop residue will help into that. So, as a modeler, when we simulate soil carbon, we need to understand the soil, plant, and atmospheric relationship.
Hmm.
How the When I start from atmosphere, how water pull, like evapotranspiration, drives carbon dynamics. And then we come to the plants, we need to understand plant modeling, how carbon is going through different phloem to different part.
Hmm.
And then we need to also understand the soil carbon dynamics, root layer, different roots in different drought levels. So we need to understand those components to simulate soil carbon. And when we simulate soil carbon, we need to understand that we need long-term data sets to simulate soil carbon. So the data layer should be precise, as well as we need to have quantifiable data so we can simulate the models.
A really interesting topic, and I'm going to move into you. You have in my hit sheet for you because I get a hit sheet for all my guests.
Mhm.
There's a a comment about to ask you, how does a circular bioeconomy in ag play role in climate change scenario? But Before we get to the real question, what's circular bioeconomy? This is a new term for me. So what's circular bioeconomy?
Oh, this is a great point. So, American Society of Agriculture and Biological Engineers.
ASAB, all the smart guys go there and the gals.
Yes. So they adopted last year, 2022, they adopted circular bioeconomy system as a part of ASAB. And you'll be surprised to know Dr. Verma from Georgia, he started Circular Bioeconomy System Institute. So the goal of circular bioeconomy system into ag and natural system is to use minimum input
Hmm.
to get maximum output in terms of long term uses of resources, and then how we can replenish or gain back to the system. So circular bioeconomy is a term, advanced term we can understand in terms of regenerative or sustainability. So if you combine regenerative and sustainability at one platform, it brings to the term called circular bioeconomy system. For our ag system, we need to understand different component of circular bioeconomy system: farm size, what kind of resources we use. So right now, this year we have annual meeting of ASAB in Anaheim, California, where we have 1 day workshop on circular bioeconomy system, where we planned actually so that we can include the farming system experts,
Hmm.
engineers, bioeconomists, especially economists who are working on natural resources, and then social scientists. So it's a combination of these people from these four domain, and then we discuss more on how best we can recommend some technology for different small farm to large farm. And I heard from different experts like Dr. Bruno Basso from Michigan State and Bram Verma, Jim Jones from University of Florida. They're planning a consortium kind of thing of researchers who can work on sustainability, regenerative, using data science in agriculture, so that we can have recommendation. I am pretty much sure that the funding agencies will have a lot of funding call on circular bioeconomy system in next 5 to 10 years, as experts says.
Well, that's why I love this podcast because I learn more every time I do it because it's a concept I'm very well familiar with, but the terminology is new to me. So I'm gonna have to holler at my engineer buddies and get even more conversation about this and find out where it's going. But leave it to the engineers to make sure that we have good terminology and good criteria for everything.
It's time for our famous three. Did you know that on average you lose approximately 1 bushel an acre during harvest? Header loss and threshing loss due to wear and tear on your equipment can lessen your yield and profits. CNH Reman Wear Parts is a drop-in ready solution made from high-quality steel that lasts longer than the competition and is covered by an industry-leading 24-month warranty. CNH Reman is helping farmers have on-time delivery of their harvest. Visit your local Case IH or New Holland dealership for details.
So a great time. We're already out of time, Prakash. So I'm going to move us into our final three wrap up questions. So when you're working and you're doing some complex stuff, models are always something that's a little bit outside of the purview, and it takes a lot. What is a go to resource for you when it comes to your research?
The go-to resource is always field.
Hmm.
When I say field, I always look to the plant and soil at the field to collect data.
Hmm.
That is my go-to resources. But there are a lot of websites. When I work on satellite data, always I prefer USGS Earth Explorer, where I
Hmm.
get to those imageries. And then we also work on different Harvard Dataverse, where we get soil data, global data sets. And then we have climate data sets from UC Davis. So these are major data sets we look for global analysis. But for my studies, I always rely on the data from the field.
Fantastic. So in your free time, what's your favorite leisurely activity? What do you do in your free time?
I love to play musical instruments. I play drums, and then I love cooking as well. I do camping with my graduate students, camp on the weekends as well. So that is a good pastime.
So I got to know what's your favorite dish to prepare?
I love to prepare curries,
Uh huh.
especially because it comes with my childhood palate. So I love to cook curries.
Fantastic. And finally, where do people go to find out more about your research program?
They can reach out to university website, Mississippi State. There is a PSS, Plant and Soil Sciences, mississippistate.edu, where pss.msstate.edu, where you can find me and my profile. And very soon, I'm releasing a separate website for our lab as well,
Mm,
and that will be publicized on different social media like LinkedIn, Twitter, everywhere. So we'll publish that, and I'm very active on LinkedIn and X, where we publicize or distribute the news or positions in our lab. So yes, so LinkedIn, and
fantastic. Well, folks, that wraps up another episode of the Crop Science Podcast Show presented by Wyzenetics. Thanks for joining us today with our guest, Dr. Prakash Kumar Jha, Assistant Professor of Agriculture Climatology in the Department of Plant and Soil Sciences of Mississippi State University. Folks, subscribe to our channel. If you like what you hear, hit that button to subscribe so you get the notifications on every release. Share this video with your friends and colleagues. And of course, leave a comment if you have any questions or suggestions for a new guest. Prakash, thank you so much for joining. It's been an absolute pleasure.
it is my pleasure. Thank you, Dr. Arnold, for having me. I love your podcast.
Thank you.